Greetings, detectives. Mrs. McKay here, and we are on our last clue, our last learning target clue for Case 6, Motion Madness. And our learning target is I can construct a parallelogram. So go ahead and write the word parallelogram. So it's parallelogram. Parallelogram. An equilateral triangle, and inscribed hexagon, using a straight edge and compass. So we have spent some time in our last clue. We learned how to use a straight edge and a compass to create a rhombus and how to create a square. Now we're going to use our straight edge and our compass, and what we learned from our last clue on how to create angle arcs and equilateral or congruent line segments, we're going to use that same information to create a parallelogram, a triangle, and an inscribed hexagon. All right, so let's start by first reviewing a little bit of vocabulary. Let's remember what an equilateral triangle is. Tell me, what is an equilateral triangle? What are some characteristics of an equilateral triangle? Well, we know that a triangle has three sides, and the thing that makes an equilateral triangle unique is that it has three equal sides. Okay, and our next thing is a parallelogram. What can you tell me about a parallelogram? Well, we know that a parallelogram has four sides. It's a quadrilateral, and two sets of sides are parallel. Okay, so it's like a rectangle that's been pushed over. All right, so parallelogram has two sets of equal sides. Those sides are parallel, and also two sets of equal angles. Those two angles are equal, and then those two angles are equal. Okay, what can you tell me about a hexagon? Well, a hexagon is a six-sided figure, and we're going to deal with regular hexagons that have six equal sides, six equal angles, and one thing we also know about a hexagon is that it has a center of rotation with these angles of rotation that are 60 degrees each. Okay? The next word you may not know, and that's the word inscribed. Inscribed. Inscribed means that something is inside a circle. Okay? So let me see if I can make a circle. So there's a circle. Okay? And when we say something is inscribed, we say that it is inside the circle. It's inside the circle. And that means, like, I'm going to inscribe a square. Actually, it's a rectangle. And what that means is that every point of my polygon, of my rectangle, touches the edge of my circle. All right? Every point touches the circle. So inscribed, I say that the rectangle is inscribed inside the circle. All right? The other thing that we can do is we can say circumscribed, circumscribed, and circumscribed means that we're talking about the circle. So a circle circumscribes, goes around the polygon. So if you're talking about the circle, you say that it's circumscribed, in that it's basically talking about the same thing. It's just that circumscribed is talking about the circle. The circle circumscribes the rectangle, and inscribed talks about the rectangle. The rectangle is inscribed. So inscribed talks about the rectangle, circumscribed is describing the circle, but they're both describing the same thing, okay? A parallel, some quadrilateral or some polygon inside a circle, okay? All right, let's get started. Let's go ahead and talk about equilateral triangles. Now, we already just got done saying that an equilateral triangle is a three-sided figure, and all three sides are the same distance, the same length. So each side is congruent to the other side. So what I'd like you to do is I'd like you to think about what you know about triangles, about using a compass and a radius, and see if you can figure out how you would construct an equilateral triangle using the length of ST to be the length of your side. And hopefully you can see exactly where you would put your compass, how you would make your arcs, because you see my circles there, and where you would make your third point. So see if you can try that. Start by putting your compass sharp point on the S and measuring across till you get the pencil on the T. So now you have your compass being the same length as ST, okay? And you're just gonna make a circle. You're gonna arc up until you kind of come up to the top here, and you want to make your arc big enough that you know that you're going to cross over it. And then you're going to pick up your compass and you're going to turn it around so that now your sharp point is sitting on the T and your pencil is sitting on the S, and you're going to make a new arc from the S. You're basically making a circle with a radius of ST, and it's going to cross up here. And where those two lines, where those two arcs crossed, is where your new point is. So you can create a new point. Let's go ahead and call that R, point R. And then you take your straight edge, and you should be able to connect S to R. But before you do that, just make a double quick check and use your compass to measure S to R and then R to T to make sure that they are the same distance, the same length, because what we're doing is we're creating an equilateral triangle with all of our sides being the same length. And then you can let's try this again. Connect S to R, and then connect T to R, and there we have just created our equilateral triangle. Okay, so that was really just using what we learned last time about arcs and being able to make arcs, and really what we're doing is we're making two circles that are crossing, and where those circles cross is where our new point is, and we know that the line segment that connects those 2 points is congruent to the line segment that we use to make the radius of that circle. All right? Now, also, I have written out the instructions briefly. I didn't spend a lot of time on them because we've been practicing this, and you should be getting pretty good at constructing. So the instructions for constructing a triangle are on the in the margin over there. Let's work on a parallelogram. Now, what do we remember? What do we know about a parallelogram? Let's remember that a parallelogram has 4 sides, 4 equal sides, right? So we want a parallelogram that's going to look something like this. And what I want to have you do is create a parallelogram that has a side right here, or a vertex there, a vertex there, and a vertex there. And this is so AB or BA is going to be one side of your parallelogram. So you're going to need to make another side that's parallel to AB, and I want you to do it right here at C. That's where I want it to start. So the tricky part about this is I can certainly take my my compass and measure B to A, and then I can go over and I can look at C and I can kind of stick my compass there, but I'm not sure where I'm going to actually measure it, am I? I mean, I could kind of maybe guess, but do I put my pencil here or here or here? Where exactly is my pencil going to go to make this parallelogram? So I need to think a little bit about perhaps what I did up here, making a triangle. Because what I really need is not only the length of the side to be the same, but I also need this angle to be the same. So I need to be able to make a triangle. I need to be able to make a triangle out of A, B, and maybe just put it over here somewhere. And then I can create that same angle over here on the C. So let me show you what I'm talking about. The first thing I want you to do is I want you to go ahead and put your compass point on B and measure A. And you can see that I have this kind of light colored orange circle that's being made around this BA or AB radius. So I'm going to take and make another circle from BA, not from BA, but with the same radius as BA, and I'm going to start at C, and I'm going to go up and make a new circle from C. So I'm going to go up here, and I'm going to kind of arc it up here, because I know that this is where my other point is going to end up, somewhere up here, okay? So and then I have to figure out where it's going to cross. So what I'm going to do is I'm going to take my compass, and this time I'm going to make a triangle. I'm basically going to use my my A. I'm going to put my compass point on A, and then I'm going to just come down to the ray BC here. I'm going to bring my pencil down to ray BC so that it's touching, okay? So I'm going to come down, and I'm just going to come down, and I'm going to touch this ray. So, and once I touch it, I'm going to make a point, okay? So I'm going to make a point from here to here. And then I'm going to make an arc. I'm going to measure this, okay? So I've measured that. I don't really have to make the arc. I just have to measure from here to here, all right? Once I've measured from there to there, then I've made this new point, and I'm going to call this point, actually I don't know if that's where my point is or not. Now I'm getting myself a little confused. Yeah, that's probably where it is. Yeah, that's right. I don't even have to measure. Actually, before I do that, before I do anything here, I need to measure. So remember, I made this circle right here. I made this circle here, and this actually makes a point right there. Okay, so let's label that point let's see, I said create a triangle with side AB, create a congruent triangle at point C. So let me just, I'm not going to call this point C, I'll call this E. Okay, so when I started my triangle or my arc, when I made this circle, I had this point here A, and I went ahead, and this measurement of B, and I went ahead and brought my arc down and I made a point right there. Okay, I crossed it and I called that point E. Now I'm going to use my straight edge to actually just draw this triangle right here that I've created. Okay, all the triangle is doing is it's helping me create this angle, because that's the angle that I want to reproduce. I want to make a congruent triangle, and mostly I want to make a congruent triangle that is this angle B. All right, so I've already copied this circle here, right here, over here on the C. Okay, I went up here and I have the same length, and I created this arc here, because I'm eventually going to find where it crosses. I'm going to make something similar to this point A. But now where this circle hits, let's go back to my kind of circle around the ABE thing, where it hits the ray is going to be my next side D. So I'm looking for where this circle comes down, and I'm going to bring it all the way down, all the way down, all the way down, and also mark here where it hits the circle. Okay, because this side right here and this side right here are equal to each other, aren't they? They're two equal sides, because they both have the same radius of this circle. So I'm doing the same thing. I'm going to create this point here, but I need to find out where up here this point is going to be. So then I have to take my compass and measure from A to E to get that distance. And then I'm going to go up here to this new point that I created that's sort of in E prime, but we'll call it, let's see, this was ABE, and I want to, I'll have this because I want this point to be D, so this will be F. So that's going to be F. So go ahead and label that F. So now that I've measured with my compass A to E to get that distance, I can put my point on F, and I can actually then create this new circle right here measuring, and you can see where it crosses, and now I've created where D goes right there, and that's point D. So all that I did in creating a congruent triangle, so I did a triangle here and I copied it over here. The main goal was to be able to create my parallel side, which is CD. Okay? And what I was looking to do is I was looking to create this same angle right here. Okay? Now that I have my parallel side, see, that angle is equal to that angle. So angle B is equal to angle C. Now that I have my parallel side, and I know that they are the same, that this angle is the same, because I have two congruent triangles. I have this triangle is congruent to this triangle, and the sides are congruent, so this side is congruent to this side, and that's what I wanted to do, and this angle is congruent to this angle. So now I have the two parallel sides of my parallelogram. I have this side BC is the bottom, and my last side to connect is AD right here. and I've created a parallelogram. A, B, C, D. See that? Okay, so really that was everything that we've already learned, but we're using it to create congruent angles and congruent triangles to then create that parallelogram. Now, let's talk a little bit about inscribed polygons. When you are inscribing a polygon, we're going to start by inscribing a hexagon. One thing that we need to remember is that here's my circle right here, and it has a hexagon inscribed, and I want you to notice that every point of the hexagon touches the circle. Okay? Every point touches the circle. So let's go ahead and do that. Let's go ahead and put little points here. There's a vertex, there's a vertex. I don't mean every point of the hexagon, I mean every vertex of the hexagon touches the circle. All right? And if we could find the center of rotation, we would see that the center of rotation of our circle is also the center of rotation of our hexagon. It's the center of rotation of our hexagon. Now, I want you to go ahead and make the diagonals of this hexagon. Just go ahead and explore and tell me how many diagonals there are in this hexagon. So go ahead and do that. Create some diagonals and count them. You should have remembered that diagonals are different from a line of symmetry in that diagonals connect. And actually, I don't really want you to do all of the diagonals. So don't do all of the diagonals. I want you to do all of the diagonals that are lines of symmetry. Does that make sense? Because I don't want you to do all of the diagonals because I don't want you to do this diagonal to this diagonal or this vertex. I want only the diagonals that are lines of symmetry, but I don't want lines of symmetry that aren't diagonals, okay? So when we did that, we found that there were 3 diagonals that went through the center of rotation that were also lines of symmetry, and they actually create our angles of rotation. So what do you see, aside from the 3 diagonals, what other shape did we just divide our hexagon into? It was divided into 6 triangles, wasn't it? So you can see, here's a triangle, 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 and here's a triangle. All right? What do you notice about these triangles? Well, you should notice that every triangle has a radius as its side. Do you see that? So that means this one is equal and this one is equal. This is equal, this is equal, this is equal, this is equal. And the other thing that you should notice is that this is 60 degrees here. This is 60 degrees, this is 60 degrees, 60 degrees, 60 degrees, 60 degrees. Well, what we've just created is equilateral triangles. And I'm going to show you on the compass how they are equilateral. All right? So that means that this side, which is the radius, is also the same length as this side, which is touching, the 2 vertices are touching that. So what I'd like you to do is I'd like you to watch this video on how I actually inscribed this. And you might be thinking about how you can do that. You might think about how you might be able to inscribe this this hexagon inside this circle. But go ahead and watch this so that you can get an idea, and then you'll get a chance to do it. Okay, so what I did was I have a circle with a center of rotation, and I'm basically drawing the radius. I'm labeling it with 2 different points, So I have C for center, that's the center of my circle. And now I'm going to measure my radius. And I'm going to use my radius and I'm going to mark from that point that I created another mark on the circle on both sides. So I've just created two more points. So now I have 3 points around the edge of my circle. And I'm going to connect my 2 points. I'm going to connect those two, and then I'm going to connect those two. You can see the beginnings of my hexagon. Now I'm just going to also put a few little dotted lines so that you can see where I'm creating these triangles. Those little dotted lines aren't really necessary. They just help me to see where I'm creating triangles. Now I'm going to take my compass again and I'm going to measure that same distance of the radius, and I'm going to start at a different point, and I'm just going to keep going around the circle. So I basically have measured, then I put my point on the point of the compass on the last point, and I make a mark along the circle. I move to the next mark, make a mark along the circle. I'm going to measure the radius one more time. I just keep double checking and measuring my radius, and then I'm just moving along the circle from point to point, measuring the next distance. And you'll see each of those marks is now turning into the point. And I have 6 points around the circle, and they should all be in equal distance. And I'm going to go ahead and fill in my dotted line so that you can see and then connect my points. So I'm connecting the top 2 points, making the top of my hexagon. Now I'm going down along the side, and I'm basically connecting each of those points. At the same time, I'm connecting all of the radii, just so that with dotted lines, just so you can see the triangles being made. Looks like I didn't line up very carefully there. I was being sloppy and I was in a hurry. But you can see that I have now created my hexagon inside the circle. Now it's your turn to try that. You go ahead and try that. So let's start with the green circle. And you need to find the circle center. And I've actually put the circle center. It's right there. You can find it. You can find it because these circles have a radius of 3 marks. So 1, 2, 3, 1, 2, 3, 1, 2, 3. All right? So once you have created your center of your circle, now you just need to measure a radius. And I don't care where you measure your radius, okay? You can start it anywhere you want. I'm going to do it so that it's easy for me to draw because I can't use a compass tool when I'm using this program. But you're basically going to take your compass and you're going to start at your center point, and you're going to measure across to the edge of your circle, and I'm going to do it right here, but you could do it up here, 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 here. It doesn't matter where you start, okay? It really doesn't matter where you start. But I'm going to do it right here, okay? And then you're going to, once you get that measured, and I'm going to go ahead and just use very thin lines, maybe this color. Once you get it measured, then you're going to take your compass point and you are going to measure from, put your point on this end, and you're going to measure up the same distance, and it'll probably be about here. Wherever it is, just put a little mark. Okay, this distance from here to here needs to be the same distance as from here to here, all right? And then that'll be your next point. And you can actually go ahead and just go around the circle and see. And hopefully, if you keep measuring this distance from here to here, and then measuring it across onto your circle, and then measure, and then now put your point here, the point of your compass here, and measure down again. You should come to right about here. And then it will happen again, right about here. And then again, right about here. And then your last one should come right back to where you started. So that you should have 6 points. 1, 2, 3, 4, 5, 6. And then you just need to connect all of those. So draw a line from here to here. Oops, meant to make that blue. So from here to here, and then from here to here, and then from here to here, and you get the idea, right? You go ahead and finish connecting those points, and then go ahead and draw in your maybe with a different color or a lighter pencil, draw in your triangles the same way that I did, just so that you can see how you've created 6 triangles. Being able to do that helps you then to know how far to go around your circle. All right? Now, let's use that same idea, and this time, let's go ahead and create a triangle. Always when we do our triangle, we need to start at our center of rotation. And go ahead and measure your radius. And get the length of your radius again. And now what I want you to do is I want you to think about how this radius is going to help us create a triangle inside this circle. Well, how many sides does a triangle have? How many sides does a triangle have? Well, it has 3, doesn't it? Has 3 sides. So that means that somehow or another I have to be able to make 3 points that get connected around this circle, and they have to be the same distance from each other. Well, when we made a 6-sided figure, a hexagon, each length of the hexagon was the same distance as the radius. So if I want to make a 3-sided figure that rotates, instead of 60 degrees, 120 degrees, because remember, a triangle, if we were going to be rotating around from one point to the next from the center, it's actually 120 to get all the way around the circle. Then, when I'm talking about my big triangle, then perhaps I need to make the length of my triangle twice as long as the length of my hexagon, because my hexagon had 6 sides and my triangle is going to have 3 sides. So let's try that. Why don't you take your compass and measure this distance, and then starting here at this point, go ahead and mark it at the same place that you started marking it on the for the hexagon, but then go back down and mark on this side like this. And what if we connected those 2 points, instead of using the distance between each point. We connected the two exterior on either side of this point. So what if we connected those? What if we did this? And we drew a line, use our straight edge, and we drew a line from that point to that point. And then I can either use my compass again and go two more over, 1, 2, and connect, or I could just connect this way, take my compass and measure this new length, right? This new length that I've just created, and use that to measure from this point over to here. So I can do it two different ways. I can use the length of my radius, and I can measure from this point over to here. That would be one length, but then I've got to go another one up here, okay? And basically make my mark right there. Or I can just measure here, take the measure of this length, and then go across to where it, swing it across to where, starting here, swing it across until it touches my circle, and then make my new point. And then I'll go ahead and connect those 2 points like that. And then you can see that I connect these 2 points like that. And I've just inscribed a triangle. All right? Let's try one more. Let's try inscribing a square. And we'll do it on this orange one. We're going to try inscribing this square. Now, the thing that we need to remember about squares is we need to remember that a square has 4 sides that are the same length. And we also know that a square has diagonals, 2 diagonals. And those 2 diagonals actually are perpendicular to each other. They make right angles. So what if we used what we learned last time about creating a perpendicular bisector, and we created, using our compass and our straight edge, we created created the diagonals and then connected the diagonals to inscribe our square. So let's start again with our center of our circle, which is right there. And then let's take our straight edge and create our first diagonal, okay, by taking our compass, all right, and measuring from the center of the circle to the edge of the circle. Now that we have a radius, we can go around, okay, and start on this side. Or actually, we don't even need to do that. We don't need to use our radius at all. We can, once we have our radius, we can take our straight edge and extend our line segment, okay, so that now we have the diameter, all right? So we've drawn a line from one edge to the other edge, okay? And it goes through the center. So we know this is a radius here, and we know this is a radius here. Now we have a line segment. Let's go ahead and give it some dots. Let's give it some points. So we'll put our point here and our point here, all right? And now let's see if we can remember how we created a perpendicular bisector. Well, what I asked you to do when you created your perpendicular bisector was to put the point of your compass on the edge of your point, okay? On the edge, on the end point, and extend your compass more than halfway, all right? So, and then once you've extended it more than halfway, and you can actually extend it the full diameter if you want, okay? And you're going to actually, but I'll just do it right here. And we're going to swing up, and you're going to make your mark up here somewhere like this, okay? And then you're going to swing down and make your mark somewhere down here. Remember that this distance to here and this distance to here are the same, okay? And it's longer than your radius, okay? So you're swinging around. Then you're going to pick up your compass, and you're going to put your point on the other end, and you're going to use that same distance, and you're going to swing around this way at the top and at the bottom, okay? And once you have your two intersections, then you just need to connect those with your straight edge. So you're going to draw your straight edge through those 2 points, and you're going to go to the edge of your circle. So your perpendicular bisector has to go through your center of your circle, through your 2 points that you created, okay, and touch the edge of your circle. Once you've touched the edge of your circle, you've created 2 more points. And once you have your 2 points, you now have 4 points, A, B, C, and D. And you've created the diagonals of your square. You've actually created the diagonals of your square. So now you just have to connect those 4 points. I'll use a different color. And when you connect A to B with your straight edge, and then B to C with your straight edge, and C to D with your straight edge, and D to A with your straight edge, you've just created a square. And you've inscribed your square inside a circle. And the key to that was using your diagonals. All of these, it was important about using your diagonals, wasn't it? All right. That is all I have for these constructions. This was constructions inside circles and just a few other little constructions reminding us how to do that. Go ahead and write yourself a key idea or two down at the bottom, and I'll see you in class.